So now in this part we will learn how to download SRTM DEM from Google Earth Engine, and that will use to create a hillside map and a 2D and 3D map using ArcGIS and ArcScene. So many of you may know that Google Earth Engine is a online GIS data processing platform. This is basically a WebGIS platform, and it is very simple to use. I will show you how to download SRTM DEM from Google Earth Engine. So let us go to this Google Earth Engine website, and this platform contains large number of data. Let's say for example landscape or sentinel optical data, sentinel-1 microwave data, various your climate data. A large number of data sets are available in this platform. Basically we'll be exploring this code editor. From platform you can go to this code editor, and many examples are available and many resources are also available on Google. You can open your existing codes for test run. So as we are going to download SRTM DEM, I'll just type SRTM DEM. If I come to this example section, many examples it is showing which contains the keyword SRTM. Let us open this first one. So here you can see there is one variable called image, and it contains the SRTM 90 meter DEM data. There is a map center. It used to indicate or zoom in that particular area. This is the longitude and latitude, and then zoom level. If you increase the value, it will give more zoom version. And for display you can use this code map.add layer. Here you have to add the layer you want to display, the minimum maximum values, and the output name. There will be one more tab here available. Once you run this code, the tab will call layer, and you will get this name here. This name will be available there, and here are some tool you can use to pan your area or create point, line or polygon or rectangular boxes. Let us use this example given here, but instead we'll try to find use the SRTM 30 meter DEM. So to browse data you can just type here SRTM. Here you can see the second one is the NASA SRTM digital elevation 30 meter. So you can use this data. So once you open this pop-up window, you can see here the name of this product. You can just copy this product name and then replace here. So now here we have not defined any boundary. So if you just run this, it will zoom in this particular zoom center or set center, and then you can see the global DEM data. Okay. So our study area is located somewhere near this place. So if you know your study area, latitude, longitude, you can use that. Otherwise you can also add your shapefile study area boundary. We'll use that method. To do that, I'll go to this asset option, asset tab. From new shapefile, I'll add our delineated watershed boundary or study area boundary. So before adding it, let's just go and check. These are the allowed extensions. So your shapefile should have these files. Excluding these files, you cannot upload other files. So all these files are not available for us. So whatever available, let us just add .shp, .cpj. If you check, all these file extensions are allowed. So make sure that you are attaching your allowed file extension. Let's just rename this file maybe micro watershed. Now you can click on upload. You come to this right hand side task option. This one I recently uploaded. Here it is getting uploaded. It will take some time, maybe 1 to 2 minutes time to upload. So while it is uploading, let's just do some modification here. So this variable image, it includes the entire global DM, but we have to crop this using our start area. Let us take variable image 1, and here to crop an image you have to use this dot clip function. We have to define our study area name here, and this one let us add comment. Or if you know your study area boundary, you can use that. For that, what you have to do, you have to change this to center object. It is not taking. You can see the color is still black, so that's why that means it is not recognizing this thing. Center. Yeah, you can see the color has changed. This means this function is correct. So our shapefile is now added. I'll just click on refresh here. This is our micro watershed. I'll just click here. It is showing its location on a global map. I'll just click on import. As of now, it is added as table. I'll just define this as geometry. So we'll click this, clip this image using this geometry boundary, and here instead of latitude longitude we can just write geometry. If you want a default zoom level, just remove this zoom portion. Now in our map.add layer, here we will visualize image underscore 1. Let us now run this. See, this layer option has appeared here. I can click on this lock, so this window will not go away. It will always show this list of images available. So as of now we are getting an image. To revise this color appearance, we have to check. So as of now minimum value is 0 and maximum value is 3000. You can check. You can go to this inspector option tab. Once you go there, you will get this kind of your cursor. If you click, you will get an elevation value for that particular pixel. So this black is the lower value ranges. You can see 473. It's around some 500 or 70. So maybe we can use this one. Let's say 470. And for maximum values, let's check. It's close to 1300. So maybe let us take 1400. Now if I run this again, it's looking much better. But if you want a colorful visualization, you have to add a palette here. Palette, within this box you have to define the color. Maybe these three colors. Let's just run again. Working, maybe it requires some more modification. This minimum maximum value we have to write in this way. Still it is not working. Let me see some example. Oh, sorry, I just misspelled this. And it is, yeah, now it is working. So you can download this data. To do that, we can download this data in Google Drive. So you can search for export to Drive. So there is a Google Earth Engine developer page. You can get many code available here. So this is the option export image to Drive. I'll just copy this portion, paste it here. This is to export image. Now our image is image_1. Description image, let's say micro watershed. Folder, this is not required. I remove this will be uploaded in my Google Drive in the parent folder. So region, here I'll write geometry, scale 30 meter, max pixel. These things you need not to change. I can save this. DEM. I can share this code with others, but the only issue will be this geometry cannot be shared. As of now, we have to share this geometry in a different way. So, and again, what we'll do, let's just run this and see what it is providing. So see, you can just see that there is a notification in task. It is asking to run this. Basically, if we click on run, it will export my image to Google Drive. What I will do, I will create one more geometry. Instead of the small micro watershed, I will take a bit larger region. I'm using this rectangular toolbox. Oh, sorry. So you can change this depending on your study area. So I have now defined this entire area, and once I have added here, you can see there is a new variable geometry2. So I will use this one. I will again create a variable image_2. This time I will again image.clip geometry2, and to visualize, just copy this line and paste it here. Here I will write SRTM2. I run this. You can see this geometry is added here. I can untick. Then from viewer it will go away from viewer. In our geometry, the center object, previously it was geometry, so let us add geometry 2 here. So it will give us the entire view of this rectangular area. You can see like this is our study area. You can see the other your nearby uh, regions. So we'll use that larger region to create our micro watershed. So I'll export this image underscore 2. I'll run it again. Now here I'll again run here. So it is giving a pop-up window. The scale will be 30 meter. Exported file name will be image micro watershed. So let us change this, maybe SRTM DEM micro watershed. We'll export in GOT format. Click on run. It will take a couple of minutes to export this DEM. Save it again here. I have to open my Google Drive. This will be uploaded in my Google Drive. Let's just wait for a couple of minutes. Yeah, now you can see the tick mark. This means the task is completed. Let me reload my Google Drive. Yeah, you can see this is the DEM. Yeah, here is the file. I'll just download it. This is the folder I am working. I have downloaded. Now let us open ArcGIS. Click on this add data and add this DEM. Oh, sorry, by mistake we have downloaded the smaller version. We have to rerun our code. I'll just remove it from here. Basically in region we have added geometry, but we have to add geometry 2. Just right here extended. Because of this geometry it has taken a smaller area based on the study area, our micro watershed. Now I have revised it to geometry 2. Now it should take the extended so let's replace this SRTM DEM, rerun this. You don't have to change anything here. Maybe this time it will take a bit longer time. Previously the exported DEM was quite small. Now this is 5 to 10 times larger than the previous one, so it may take some time. So by that time let us go to ArcGIS. We'll click on this Arc toolbox. Here we have this data management tools, projection and transformation, then raster. So this project raster tool we will use to reproject our data. So let us just open the previous one by right click on it or double click. Let me just go to this, right click and then properties, general source. Yeah. It has a different projection, but linear unit is meter. So then we need not to reproject this DEM. And reprojection is not required with this DEM. We can directly use this for our watershed delineation. But if you want to reproject in UTM projection, here it is SNAD 1983 USA LVARs. Let us just reproject into UTM projection. So we'll use this project raster tool. It has, you can see, it has completed the export task. Yeah, here it is. SRTM micro set extended. Let's just download again. ArcGIS. Just add it again. We'll remove this one. So this is our extended DEM data. As you told, we'll reproject this. It is very simple. You have to just add your input. Then click on output location. We'll go to test DEM micro set. Write UTM, and as the extension you can use .tip. I prefer using .img, whatever you want. Either you can use img or tip. If you don't add any extension, by default it will take the grid format. Output coordinate system, here we have to define. So we have to check UTM zone for this region. UTM zone map of India. So this zone belongs to UTM 45. Okay, from this part. So you can use this one, otherwise you can click on projected coordinate system, here UTM, then WGS84 northern hemisphere, and zone 45 you can choose from here also. And you don't need to change any other thing, just click on OK. It is showing geographic transformation. Actually it was already in a linear unit, projection unit, so that's why it is asking for geographic transformation. But if you convert a GCS data into UTM projection, it will not ask. Most of them are available for US, but for non-US region, let's just take from here. Many of these options here. I remove, now we can remove this, add a color here. Yeah, so this is our DM, rectified DM. Sorry, not rectified, reprojected. You just check the properties again. Now you can see this is UTM 1984, Zone 45. Okay, this is now perfectly fine. What we'll do, we'll crop this image, we'll exclude these portions. This is the no data area. If I check the values here, these are showing all 0. Maybe I'll just exclude these areas. What we'll do, we'll create a new shape file. I'll click on catalog, then redrive STM micro watershed. Right click here, click on new shape file. Right here, polygon micro watershed. Click on, you have to add the projection, so click on edit. You can import from the DM. Click on this image. This will import the projection system from the image. Click on OK. Oh, sorry, I forgot to change the type of the shape file. Polygon watershed feature type will be polygon. Yeah, now we'll click on edit. We'll import the projection from the image. Click on OK. Now this has created a polygon shape file. Uncheck this previous watershed. Click on editor, start editing. Polygon micro watershed. So the polygon shape file is created, but there is no feature. So we'll edit this shape file and create a boundary. So that's why we are using this option. Now click on this create feature tools and directly use a rectangular feature. Let's exclude the boundary pixels. Yeah. So our study area boundary is again created. I'll go to editor, click on save edit and then stop edit. Click here, take a hollow one. You can see this is the study area. Using this boundary, we'll subset the DM. Let us go to Arc Toolbox, Special Analyst Tool, Extraction. We'll use this Extract by Mask tool. In input raster, we'll add this image. Feature mask data, we'll use polygon micro watershed. And here I'll rename this file as crop. Press OK. Now I can remove this file. So this DM will use. Also let us remove this one. Yeah. So this DM data we'll use to create our. This is the 2D version of digital elevation model. You can see the higher values are represented in green color and lower values in brown color. To create a beautiful 3D map, we'll create a hillside map. Let us go to this Arc Toolbox. Then we'll go to Surface and then hillside. Now in input raster we'll add DEM. Output we'll just rename this that hillside. Will not change the azimuth and altitude options, Z vector also. Just click OK. So this is basically showing the hillside from a particular direction. Okay. We'll use, so in this hillside map you can see there is a clear visibility of the ridges and also the stream networks. You can see this particular stream is much more prominent here than the DM. One can assess the ridge here, but the identification of ridge is much more easier in this map. You can also check with reference to our manually delineated watershed. Okay. So now let us open the ArcScene and we'll create a 3D map. It will take some time to open the ArcScene tool. So first we'll add our DM and then we'll set. So here we'll keep our hillside below. Now we'll add a color to our DM. You can see higher altitudes are represented in brown and white colored and lower in yellow, then green, and then this light cyan color. Now I'll right click on this image or layer, go to properties. First we'll go to base site. So our floating surface will define hillside and the resolution will define as 30 meter. Then we'll go to display. We'll keep 50% transparency and in resampling technique we'll use cubic convolution. Now click on OK. So this is our 3D elevation map, but somehow it is not looking as I expected. Contrast, if we increase a bit. Yeah. But still it is not looking that great I was expecting. But you can see the higher altitudes or the ridges are easily identifiable here. Those are basically this white and brown colored pixel. So if you want to export this particular view, you can go to file. In export you have to export in 2D. Let's just check our desktop. Yeah, this is now exported. This is the 3D map, 3D elevation map. Let's just try once with this black and white color. Let's just change this to black and white. Or maybe what we can do here, in symbology, let us change the minimum and maximum and see if it is improving the visualization or not. It is not improving visualization significantly, but yeah, this is the approach you can try with your own study area or some different area. I think you may get a better visualization. I'll just check once again with some other color scheme. Yeah, maybe with a larger area it will look better. A smaller area it is not looking that much great. Let me just check once whether I have done this thing properly or not. Insert resolution, offset, display. Yeah, this is fine. But if you want to improve or increase this vertical exaggeration, you can right click on scene layer, click on scene properties. Here there is vertical exaggeration. You can increase the relative height between features. Another way of creating a 3D map, just click on this properties. Instead of this hillside, you just take the DEM and resolution keep 30. No transparency required. Contrast, let's just keep the default 10%. Click on OK. Yeah. So it is now exaggerated map. If you don't want an exaggeration, you can just reduce this exaggeration. Let's just try with 1.5. Yeah. You can see a 3D map here also. This kind of view also, if you want, you can export. These are the regions basically. This view also you can export from this ArcScene. So I'll stop here, and in the next video we'll delineate the watershed using Arc toolbox and also the ArcSword toolbox. Thank you.